this video, we'll be going over the answer key for Thursday, April 23rd. And we're first going to start with ionization energy. Ionization energy is the energy it takes to remove an electron from an atom. This is an endothermic process. That means that it takes energy to remove an electron. All these measurements are made in the gas state because it's really hard to move electrons from like a solid or liquid, while in the gas you can do that easily enough. And in generally, the valence electrons, or electrons that are furthest away from the nucleus, are the easiest to remove. Therefore, they have the lowest ionization energy. And when we talk about ionization energies, we have first ionization energy, second, third, fourth, etc., etc. And it's just talking about the number of electrons you have removed. So the first ionization energy is your first electron, second is the second. And the more electrons you remove, the more energy it will take. And the general trends are, when you move from left to right on the periodic table, your ionization energy increases. As you move from down to up, it also increases. So the bottom left is the lowest amount of ionization energy. The top right is the highest amount of ionization energy. So we're just going to get used to that trend. So arrange these elements in order of increasing first ionization energy. So we have In, that's the furthest on the bottom left, then Sn, then N, and F. So that's all you have to do. So ask yourself, going from bottom left to top right, what elements follow along that path? And B is the same thing. Pb, Sn, S, Cl. Now, one thing I do want to point out for this is that Pb actually has a higher ionization energy than Sn. However, you wouldn't know that unless you actually memorize the numbers, and they're actually very close. So what we're going to do is we're just going to follow our trend, bottom left to top right. Now, like I said, ionization energies grow the more electrons that you take away. Well, there is a point where you get a very large increase in ionization energy. And that's when you have run out of outer shell electrons to remove, and you now are trying to remove the core electron. So for sodium, sodium has one valence electron. So the ionization energy for that, for the first, isn't too bad. But in the second ionization energy, you're trying to actually take away a core electron, so that takes a lot of energy. Magnesium has two valence electrons, so taking away the two electrons is relatively easy, but the third takes a lot of energy. We call this like a jump in ionization energy, and that's when you try to remove a core electron. So these problems just deal with, when do we see the jump? So beryllium has two valence electrons, so the jump is when you try to remove a core. That's the third valence. That's the third ionization step. Nitrogen has 5 valence electrons, so the jump is the 6th. Oxygen has 1, 2, 3, 4, 5, 6 valence electrons, so it's at the 7th. Lithium only has 1 valence electron, so the jump is at the 2nd ionization event. And that is the end of this video. I will see you in the next one.